Hello. In this video, we're gonna build system design for video on demand platform like YouTube and Netflix on AWS using AWS serverless services. We're gonna go through high level design as well as low level design. And this system design heavily depends on the architectures built according to AWS well architected. So it's quite robust. Let's start with the features. And main features of this platform should be upload. So users should be able to upload their videos, watch videos on the platform, search for videos, and get notifications when the videos are uploaded. Main requirements for this platform is that it should be scalable, infinitely scalable, because if we are designing something like YouTube, we should be expecting user base daily million active users. It should be highly available, so the downtime should be minimal, and it should be resilient because when some error happens, it should heal itself, let's say, and continue operating without major problems. Before we jump to the design, we should know we should have some estimates, and for estimates, let's say we have 100k daily active users. Well, it's far from million active users, but for the numbers not to get too large, let's go with 100k daily active users, meaning 3 million active users monthly. And let's say each of these users are watching 5 videos per day, and 10% of the users upload videos daily, and these videos have average size of 500 megabytes. Using these estimates, we can calculate some initial costs for operating this platform. Let's start with storage costs. For storage, we will be using S3 storage. If 10% of our users will be uploading one video a day, that means 10,000 videos a day. 10,000 videos translates to 5,000 gigabytes daily, because our average video size is 500 megabytes, and that means monthly we will have storage use of 150 terabytes. And as for the cost, S3 bills per gigabyte, and there are some tiers. So for first month, our storage use would be 150 terabytes, meaning we get price of 0.023 cents per gigabyte. That means we will use up 3,450 USD. This is for first month. Second month will be 300 terabytes, and price per gigabyte will be the same. But for third month, we will get better tier because we are using already a lot of storage. So we get 0.22 cents per gigabyte, and it will cost us 9,900 USD. It will increase continually per month because the uploaded videos will continue to grow. And unless we delete older videos or move them to colder storages like S3 Glacier, the cost of our storage use will continue to grow, and consequently our monthly costs will continue to grow. We can also calculate CDN usage, and for CDN we'll be using CloudFront. It's an AWS service, and if we have 100k active users and each of these will watch 5 videos per day, and each of these videos are on average 500 megabytes, that will give us 250 terabytes of video streamed per day. And for now, CloudFront will cost us 4 cents per gigabyte streamed. So if we multiply that to 250 terabyte, we will get 10,000 USD daily, which will translate to 300,000 USD monthly. Now that the initial costs are calculated, we can start with the system design. For this, we will be using REST API, and to build our REST API, because we are using AWS serverless services, we will go with API gateway. And using this API gateway, we can build 3 main endpoints for our platform, which will be watch endpoint. This endpoint will be used by users to start streaming videos. We will have upload endpoint, and for search, which will be used to search videos. And out of these 3 endpoints, the most important and most complex endpoint is upload endpoint. So let's start with the upload endpoint. First step is when the user uploads their video, and we let users upload their videos to our S3 source bucket. And this source bucket will store original videos without any modifications. When a video finishes uploading, S3 will be configured to start our workflow. And first step of our workflow is the ingest step, and this step will be using step functions, AWS step functions. Just a brief introduction to AWS step functions. It's a service for orchestrating other services. For example, if we have multiple lambdas, we can determine which lambda will be fired after which lambda and in what case, and what happens if there is an error. And actually the icon it has is quite self-explanatory. What this ingest step will do is that it will prepare the file for further processing. And if we zoom in on that, we'll see that we have a couple lambda functions, and the first lambda function is validate function. What this lambda function will do is that it will actually determine the configuration of our workflow. So we can create a configuration in this step, and we can determine which services we will use in the following steps of our workflow. So for example, if we don't want to use certain service like AWS media package, for example, we will define the configuration in this step. Next step is media info, which is an open source software for extracting metadata from videos. And using this media info, we will extract the data from the video, like author's name, resolution of the video, length and width of the video, compression, and stuff like that. So we will accumulate all this data, and in the next step function, which is DynamoDB Lambda function, take this accumulated data and put it in a DynamoDB, because we will be using this data in the future steps. And the next and last step of this step function is invoke process Lambda function, which will actually just invoke the next step of our workflow. And the next step is the processing step, which will be using step functions, and it will also be using AWS EMC, which is Elemental Media Convert. And this is service for converting the video files, source video files, to our desired streaming type, and we will get to that soon. If we zoom in on this step, same as before, we have a couple lambda functions, and the first one is profiler. What this profiler lambda function does is it chooses template, and this template will be used to determine what kind of output we will get, which resolutions of the video we get, and stuff like that. So for example, if the user uploads a 1080p video, we want to create 1080p video, 720p video, and 360p video. And if the user uploads 720p video, we only want 720 and 360p videos, not 1080p. So this profile will determine that. And the next lambda function is submit encode job, which will basically take our original video, source video, take our template and accumulated data, and submit to EMC. And EMC will start converting video asynchronously. And when it's done, it will fire an event in event preview, which we will discuss a bit later. The last step is DynamoDB Lambda function, and same as before, we will take all the accumulated data and put it in DynamoDB. So when the video is in process of converting, we'll also save this info in DynamoDB. And we mentioned streaming formats. There are a couple streaming formats we can use, and we'll define which streaming format we want to use in a template, which we will build in Profiler. For streaming formats, we can use Apple HLS, which means HTTP live streaming. We can use Dash, which is dynamic adaptive streaming over HTTP. We can use Microsoft Smooth Streaming, and we can use Adobe HDS. Most popular ones are HLS and Dash. And actually Dash is a standard for streaming, but Apple devices do not support Dash streaming. They support only HLS streaming. And because of that, we will go with HLS. And the bigger platforms like YouTube and Netflix are using Dash, but they are packaging this Dash streaming as HLS for Apple devices. So you will be able to stream YouTube videos on your Apple device. And actually, more devices support HLS than Dash, and that's because of Apple devices. So we will go with HLS, and that means output of our EMC service will be HLS files, and we will stream these HLS files to our users. Back to our system design. When EMC is finished converting, it will save our HLS files to a destination S3 bucket. And as mentioned, it will fire an event into an event bridge. To explain briefly, it's just continuous flow of events, and you can connect any number and any kind of service to this event bridge to catch your desired events. This creates decoupling between services, meaning this workflow process does not need to know the existence of our other services. So it will just create an event in event bridge, and if you want to use that event, you can build a service and connect to event bridge. And obviously this workflow step uses DynamoDB. The last step of our workflow is publish workflow, which also uses step functions. And to zoom in on that, it also uses a couple Lambda functions. First one is prepare Lambda function. If we are using CloudFront for streaming, this prepare function will create a CloudFront URL for streaming. And if you are using some other service for streaming, it will create the URL of that service, for example, Elemental Media Package. The next step is the handle source. When we know that we already have HLS file for the given video, we can either move our original video, which we won't be using, into a S3 Glacier to make it more cost effective, or we can actually remove it completely. And next step is media package, which is optional step. If this step runs, depends on the configuration we built in the first step, that is the validate step. If we set the configuration to not use that media package Lambda function, we can skip that function. But let's go through what media package does. So remember when I said YouTube and Netflix package their videos depending on the device? So that's what media package does. Let's say we have Dash and we want to stream to Apple devices. We can use Elemental Media Package for that. So basically it will take our Dash files and stream them as an HLS to Apple devices. Also using Media Package, we can use DRM, which is Digital Rights Management, and this is also used to defend content creators' rights. Next step is DynamoDB, so it will take all the accumulated data and update the records in DynamoDB. So for a given video, it will upload the DynamoDB record that the video is finished processing and it is ready for streaming. And the last step of publish is emit event. So when this publishing event is done, that means our video is ready for going public and ready for streaming. For that, we just emit event into an event bridge. And if there is a service, so for example, we want some notification service, we can set up that service and connect it to an event bridge to listen to that event. As you can see, the publish step is not triggered in any way. It's just sits separately. And that's because we are using event bridge to trigger the publish step. That means we have set up event bridge rule. Rule is just a filter for events. Basically, this rule is listening to events emitted by EMC, and if it catches that event, it will trigger publish function. So when EMC is done converting the video file, it will trigger publish step. And this publish step also emits its own event to event bridge. And because this is a publish event, it won't trigger itself, because this rule listens only to EMC events. So that's how event bridge works. And as mentioned before, for notification services, we can set up separate rule which will listen to the events of publish. So when publish emits event, this rule will listen to that events and will trigger notifications. And for notifications, we can use any kind of AWS service. We can either use step functions, SQS, SNS, or Lambda, and do anything we want with this information. Like we can send email, we can send live notification using sockets, we can use push notifications, or we can actually send messages through Messenger or WhatsApp or something like that. An extra thing here, we can actually handle origin videos here using event bridge. So we set up a rule which will listen to the publish events, and when it catches that event, that means source video is not needed anymore, and it will tag this origin video as to be archived. And using S3 lifecycle events, it will move that video to AWS S3 Glacier or Glacier Deep Archive, or actually remove it. Okay, we have not talked about error handling, which is one of the most important steps. So let's handle the errors. For error handling, we have separate workflow, and this is quite a simple workflow. For workflow errors meaning errors from these steps or this step, will trigger Lambda function. And as I mentioned before, in step functions, we can trigger certain Lambda functions depending on the output of the previous Lambda function. So let's say we have an error in one of the Lambda functions. Instead of the next Lambda function, it will trigger our error handling Lambda function. And this Lambda function will trigger this error handler Lambda function. And this error handler Lambda function can be configured to save the detailed error info in DynamoDB or send email to the users. As for converting errors, when the elemental media converts has some error, if it has some error, it will fire an event in CloudWatch event. And CloudWatch events is same as Event Bridge, quite literally the same, because Event Bridge actually uses CloudWatch events API, so it doesn't really matter which one we use here. So when there's an error in elemental media converts, it will trigger an event in CloudWatch, and this CloudWatch will trigger error handler Lambda function, which will save the detailed info in DynamoDB and send an email. And that's our error handling. And the next step is that users should be able to discover our videos, and they should be able to search for our videos. For that, we can use OpenSearch, which is an AWS service that uses Elasticsearch behind the scenes. And obviously, the user should be able to search in this database. What this Elasticsearch does is it enables us to use full text search. And full text search means that let's say we have a title of the video, and you search with a word that is included in this title. So for example, if the video is called AWS system design and you search for system, it should show you this video which has system in its title. So that's a full text search. But the problem here is that our Elasticsearch database is not populated, and for that it's quite often that people use Elasticsearch for their main database, but for our case it won't do, because it's not as reliable, robust and fault tolerant as DynamoDB. So I'm against using Elasticsearch as a main database. But we want to populate this database with our video metadata. For that, we can use DynamoDB streams. So when new record is inserted in DynamoDB, it will trigger a Lambda function and send this new record to the OpenSearch, and we will save duplicates of this data in OpenSearch. And next and last step is for users to be able to start streaming and start watching the videos. For that, we have watch endpoint, and we will have CloudFront distribution, which will have S3 as an origin source. When the user discovers a video using search endpoint, it will start streaming this video using watch endpoint, and CloudFront will use nearest edge location to the user to stream this data, so it can be quite fast. One more thing I forgot to mention when discussing streaming formats. All of the formats we mentioned before are capable of adaptive streaming, and that means if you have low bandwidth, so if you have bad connection to the internet, you will get low quality, and if you have good internet, you will get higher quality videos, and that's good for uninterrupted stream of the video, and it can actually change while streaming. So if you start with good quality of internet, you will get good quality of video, and if your internet bandwidth deteriorates, you will get worse quality of the video. And because the CloudFront is the cache, and we still can have some cache misses, meaning the user wants to start watching the video which is not cached yet, that means it's a cache miss, and it will go to origin, which is our S3 destination bucket, and it will start streaming from there. So that means we will have a load on the destination S3 bucket, and that's not desirable because of a couple reasons, one of which is bad user experience, increased costs, and unnecessary load on the S3. For that, we can use extra layer of caching called Origin Shield, which is also an AWS service. So when we get a cache miss in CloudFront, after that it will check in Origin Shield. So we have way less chances of user getting in cache misses in both layers of cache. Yeah, that's pretty much it. I will include all the detailed information about step functions and these services in the description, so if you're interested you can follow up on that, and you can use this architecture as you wish. If you have any questions, don't hesitate to ask in the comments, and if you want to see more of this kind of content, feel free to subscribe. Thanks for watching.